Good. So our final answer would be 2a plus k multiplied by a minus b. We have the third one. Talk about. Prepare yourself if you are coming to the board again. Okay. Are you still solving? Who has finished solving? Who has finished solving? I'll read it then. This is Ibrahim. Ibrahim. Okay, so thank you. Okay, so we go to transfer. Oh, don't do everything. Just go and expand the bracket. Let's open the bracket. Just expand the bracket. Yeah, that's something like this for like moving brackets. I just want everything. You want to do everything? Yes. Oh, what's it? Oh, use the national. Right here, there as well. Is it correct? Is it correct? Okay. Let's move on to type 3 and type 4 together. We are looking at quadratic binomials. Quadratic binomials of these given expressions. So we have expression like x squared plus bx plus c. This is a quadratic binomial of type 3. And type 4 talks about the coefficient of the x squared. Ax squared plus bx plus c. So let's talk about the fourth term because it covers the 10th term. So this one without coefficients is 1. And this has a specific coefficient greater than 1. That's why I can see the A there, right? Okay, so what strategy are we going to use? So look at this. Any expression with this form cannot be either taking a factor out or group it in twos in terms of the method two that we have just talked about. Method of grouping within brackets. It is already in three terms. So what you need to do is put up a strategy that will make the three terms you need to use to be in four terms. Then you can apply the method of grouping. Then you find a common factor. So after doing this, by showing all the necessary procedures, we also go by the use of calculator to see how the calculator can also help get the result. Do you get it? So let's do this without using calculator. Then we come back and see the function the calculator also will give us to get the results very fast. Alright. And then from I'm going to look at this now, then I'll put up an example to practice. So whenever you get any expression in three terms, whereby the highest power of x is 2 in one of the terms, that will give you the name quadratic. Quadratic. If the highest power of that x is more than 2, then about polynomials, then polynomials, then we have a different way to deal with that. So this one is talking about quadratic. So we have here the A, so look at this strategy. Most of you are very good by using the calculator. But when you take the calculator from you and ask you to do it, you get back to square. So we just look at how we can do this. Use the coefficient of the I of x to multiply the constant that I've been giving to you. So we have the A multiplying C, whatever number it is. So you get A multiplying C. The result that you are going to get, find its factors. Find its factors. The factors must include the positives and negatives of the same number. Then you combine these two factors by adding them. That's the one that will produce the middle term. So the middle term is B, the one that can produce B as a number. Then we use it to expand the middle term. Let's use a question to get the concept right. Someone is calling. Who is calling? Okay. So let's start our example from this side. Let's begin with the factorial expression of this term. So x squared plus 5x plus 6. So quadratic polynomials of the form x squared plus bx plus c. We are not equating this to 0. That's we are going to find root of the x. No. So this is still in expression form. So there is a strategy. The form efficiency of the highest power of x is what? 1. Because there is no number there. Look here. There is no number here. So it is always what? 1. Use that coefficient to multiply the constant. The constant is the number without any variable. And that is the 6 that you see there. It's not the 5x. 5x is not a constant, but there is a variable attached to it. So we have the constant to be 6. So 1 times 6. So this one is going to have, they are going to have a workpoint at this side. So 1 times 6 will give you what? 6. So this is the answer we have now. Now the answer that we are plotting here, try and find the factors. Factors of 6. So we have plus or minus 1, plus or minus 2, plus or minus 3 plus or minus 6. So if you find a factor for that, take it to the negative of the same number. Then combine these two factors, that will give you the same result as 6. And when you change the multiplication sign and put the addition sign there, it will give you a result being found at the second term. Do you get it? So let's try and do the combination. Any combination of this factor that will still produce 6, let's write all the possible combinations down. And bear in mind the result here is positive 6. So make sure your combination is a result of what? Positive 6. Negative 1 times negative 6 will give you positive 6. Give me another combination. 1 times 6 will give you positive 6. Don't repeat what you are placing in it. Let's go. Which one again? Negative 2 times negative 3 will give you positive 6. Which one again? And also 2 times 3 will give you 6. Is that all? Is that all?
Should I increase it?
Okay. Now let's look at something. Since I'm able to produce the same results as the question says, then change all the multiplication signs here and write addition signs in place. And find the sum of these two numbers. The one that will give you the same result as 5, and the second is the one we are picking. That is the second we are picking. So this will give you negative what? This will give you negative what? This will give you what? Positive 7. It's not possible this 5. This will give you positive. So we are gotten the positive 5 here. So the factor that gave us the positive 5 is the one that we are going to choose to expand the middle term. So let's do the expansion. So repeat the first term and the last term. The middle term is the one that's going to change using these two new numbers. We have and apply the variable to the two of them. So 2x plus 3x. Now we have gotten 4 terms. Now we apply the type 2 to this concept. Method of grouping. So we have here to be x plus 2x, 3x plus 6. Then we come up to type 1. 3 common factors from each group. What is the common factor from the first group? Yes, it's what? Leaving what remains? X plus.
No, this is a public school. Public senior high school.
Leaving.
Mr. Patrick, this is a public senior high school.
Okay. Then finally the answer. So our final answer is what? X plus 2, X plus 3. And that is it. All these are long words. Here is the workings you must provide. So, as being a senior high student, all these things are not necessary. We have to start with this. If this is what we do, all these steps, we still have to start with this. Let's do that. First of all, let's apply the calculation aspect. So, if you don't know the functions, then learn from today. We have our calculator, so we take all the calculators. Take all the calculators. Then Let's follow these functions. The first mode. We have a lot of functions appearing. So we need equation, right? We are not finding the roots though, but they are using this strategy to get this simplified. Okay? So choose number 5. We have different types of equations. We have simultaneous equations inside. We have quadratic, polynomials, everything inside. But we are dealing with quadratic, right? So choose option 3. Now we have the section where we insert our 4 efficients. So what you see there is the insertion of 4 efficients to the correct terms that we have been given. Now, today is the first that we are applying concerning to all these find the common factors, find the sum, changes, test, and get your 2 factors and expand a little bit. You have a lot of questions to solve in your exam when you do this. Only this will consume like 5 minutes of your time. So of course. Good. So let's do this. Now after that section has appeared to you, let's type all the coefficients inside. Starting from the first one. You can represent the second term as the first one. It has been arranged. The operator understands. Bring the first one, second one, and the last one. Don't do this. And so that the second one will be given to the first one. It will not give you the right answer. So we have the first one has the coefficient of what? 1. So just type 1. 1 to 100. First equals to. It will enter into that space given to you in the calculator. It will automatically shift to the second term. Let's move on to the second term. Positive. Good. So if it is negative, you need to apply the negative sign to the number before you enter. So positive just points the 5. Press equals to again. It will enter and automatically shift to the third section. Right. Let's do the last one. Positive. So you are going to on the positive 6. Press equals to. When you press the equals to, the 6 has also entered into the average space. Now we need a result. So check something. Press equals to again. The first result comes right. We want to skip all the finding factors issue. The operator is doing shortcuts for you. Keep the result intact. You are not finding the 0, so don't keep the final answer. Keep the result. X equals to what? The first answer is x equals to what? -2. Press the equals to again. The second answer is x equals to what? -3. Good. Now we are writing this as factors. Okay? We are writing this as what? Factors. We are going to put x equals to -2. This factor will be what? This factor will be what? This factor will be what? Very good. So we have it to be x plus 2. Then this one, this factor will be what? X plus 3. How we have gotten this? Okay. After I've gotten this, then work backwards. You get this distance down. Okay? So expand this like multiplication of two binomials. Then you place the distance step that you have missed here. Then already the answer has been given by the distance step wasn't there. So work backwards to get the distance step and complete. If this is better than changing, multiplying by factors, comparing the two factors, the one that will give you the product of the same answer, the one that will give you the sum of the middle and the two long. Are you okay? Very good. Let's look at this question as well. Serious question. Let's do something right now. So we are going to form a simple group play. So one group play for my sister. Work together, get an answer, one common answer. Use through one group. And share ideas on how to solve a question on the board. So this question is given to those in this line. 3 groups. So the next one will come to the rest of you. So we'll discuss on how this question can be solved. Then we present one member from each group. We are going to give you these solutions. Then we'll talk about it. The same question. Whereas the units, they are working in use, so you have to use immediately to get a solution. Do the work together, give it to one person. waiting for the group results. I'm waiting for the group results. Stop, Mike. Thank you. Group, what are you doing? The group is an Then one person to solve the question for us. Group 3. Take the first one. Oh, wait. You have to work together. You have to work together. You have to solve for the next time you look at it and do the same. Wait a minute. There is group 2. Group 3. If you are not done, come and continue from the board. If you are not done, come and continue from the board. Thank you. Group 3, what are you doing? I'm waiting for you here. Don't start. Group 3. You know my position, right? Try to do the same. Thank you. You can have the key. Don't copy it. Don't copy. If you are there, can give the marker to me, the take the seats. Thank you. Continue. Thank you. See, it is good to take different answers that you compare. So that you know the different ways some of you solve problems, right? So let's look at these 3 solutions on the board. So we have the concept called difference or two squares. So the person who solved this apply the concept difference of two squares. And this will factorize to be in this form, right? Good. Then also repeat the same expression here. Now we say we have 2 terms in our expression here. We have this one, we are multiplying. So minus this, so 2 terms. So we can apply the application of the common one factors. So the person tries to factorize by using common factors. So you can see H plus K in the first term, and also H plus K in the second term. So we took the common factor out, and that is the H plus K. Now, on the side of the first term, we have H minus K.
Hi,
Then this
Bar.
one minus K. So she has skipped a method and just divide the final answer for us. Okay, so what's the method that he has skipped? He has not go straight to the point of what the expansion. So when given a factorize, you have to show the remaining number before you go to write the final answer. So in this form, this one has been taken out H plus K. Then this one is left to go H minus K, then in bracket minus P. So this is the part that was taken out. You agree? Before you get the final answer. But anyway, the example. Thank you. Let's come to this one, to the same thing. The person did not do this one. The same thing. So when you are marking this kind of solution, you know you're going to consider after one answer this one. Or not really now. Let's come to this one. Okay. Trying to do something different. So this one we have very interesting one. Are you doing something interesting on this particular question? It's very, very interesting. Let's talk about this one. Let's talk about this one. Okay, so starting from here, here's the question I gave you. And she decided to rewrite this as is it equal? Are they equal? No. So let's look at the difference between them. We're having a squared minus a squared. And if they are not equal, let me put not equal to sign in the middle and do a square, then h minus a all squared. They are not equal. Okay. For this expansion, it is described as what? Difference of two squares, which the expansion says h plus a, h minus a. You find the sum, the product of the sum and difference of the same basis, right? Good. Now let's come to this one. Not equal to this because this one talks about binomial concept, right? What topic that we call under the relating mathematics? That's a binomial concept. Binomial theory. Binomial theory, right? So to use the Pascal family to expand
Okay. Can you guys hear me now? Can you hear me now? Hello? Let me know. Theophilus, let me know if you can hear me. Okay. Nice. I was trying to charge the phone, so I connected something that made the sound
Alright, so let's look at
vanish, but I'm back again.
They know how we can solve a problem relating to say. Alright, so what is say? What is the key to this say?
Thank you so much, Theophilus. And I will turn the camera on me again.
Hello, yes.
I said, look at how I look so tired, like I'm the one doing the Guinness Book of Record. Is it Guinness World Record? I'm tired. We are, I think right now it's 7 hours, 7 minutes, and blah, blah, blah. So we still have a long way, like 30 something hours to go. Wish us good luck and pray so he will succeed, okay?
Yes, I know you have different explanations to this. Give me another one. Okay, so whenever you find square root of any prime number, okay, square root of a prime number, is then at what? Say, so square root of a prime number. Now, let's look at the governing set, the rules. Two numbers, when you multiply, that gives you the same result in two. That refers to the parts. You must consider this. The two numbers that you are choosing, make sure one of the numbers is a perfect square number. If I'm not able to find any one of the numbers to be a perfect square number, that root given to you there is your exact answer. Don't give it to it. Like the 6 that we have there, 6. This is, we can't do anything about this. If it tends to break it down, it will still be root 2 times root 3. And it will still give you what? Root 6. Can't break it down. So, if you are trying to reduce a number in the square root, always consider one of the numbers you are choosing to multiply against each other to be a perfect square number. If you couldn't find any of the numbers to be a perfect square number, the effective unit is your exact answer. Are you okay? Okay. So let's take the two numbers as they are discussed. Let's take the two numbers as they are discussed. So give me two numbers, when you multiply, it's going to give you the product of the product between 7. So what are the two numbers? What are the two numbers? 9.
Theophilus, hello.
And
how many days is it going to be to do this? We are ending this on Sunday, I think around 11 a.m., 11, 12 a.m.
Root 9 times root 3. Root 9 times root 3. Then let's find the perfect square. Let's find the perfect square number from, let's find the square root from one of the perfect square number we have expressed here. So we have the square root of 9 to be, square root of 9 to be, then we just join the square root of 3 to be, because we can't find 8 whole number as an answer. Are you okay? Okay. Let's also look at the 32. Let's look at the 32. What are the two numbers that we can choose? Which one of 8 number will be a perfect square number?
And Mr. Kojo, I'm sorry, I'm not going to work for anybody. That's not my job, okay? I'm sorry, I don't do that. I came for this program because I know that it's something that is going to put Ghana on the map, because if this man wins, Ghana educational system will be respected, you know. Yeah, so that's the reason why I came for this. But I don't do weddings, just for you to know that I am not desperate, okay? And the trap you're trying to pull is not going to get me.
Which two numbers are you going to use? 4 times 2. So when we write these two numbers in the separate set, we are going to get the answer to what? 2, 2. Let's look at the last one. The last one. We have root 128. Root 128. Root 128. So what are the two numbers are you going to consider here? 64 times 2. 64 times 2. Let's write them in two separate roots. We have root 64 times root 2. Find the square root of the perfect square that we have here. 8 root 2. Here's the way we do to reduce or simplify a given set. Let's look at the strategy that you can use to add and subtract sets. So for the set concept, addition and subtraction. It takes the form A root M plus B root N. So let's talk about this one. This concept is talking about when the set is having a common term in the roots. If that is possible, then the coefficients need to be put together, or we find the difference of those if they are dealing with subtraction. So in this form, make sure the terms being contained in the roots, that expression, must be the same. So this one will give you the addition of the coefficients. Then you choose the expression of the n to be a unit added to the result that you are going to get after we have added the coefficients. It also goes the same to the subtraction concept. So this one minus b root n. And this will give you a minus b all root n. So let's take number and put them together. So example. Three root 8 plus 3 root 200 plus 2 over 3 root 162. So first of all, we need to simplify the roots. Okay, we need to simplify them. None of the roots are the same as we can apply the addition concept to solve. So first we need to do what? Simplify the roots. So root 8 to be simplified to be, so we have 3. So root 8, which two numbers are you going to use to simplify root 8? Now 4 times 2. So 4 times 2. And 3 roots. This will give you 100 times 2. And this will give you 81 times 2. In this case, don't write them in two separate cells. Just go straight to the point. Find the square root of the pepper square inside it. Join it to the one outside. So over here we have 3. So the new number coming outside will be the square root of the pepper square for price. So square root of 4 will give you what? 2. And the 2 that you are bringing outside will multiply the number that is already what? Outside. You are going to get what? 6. So 6, then you 2. This one also gives you square root of 10, 100 will give you what? 10. So multiply by 3 will give you what? 30 to 2. Then this one gives you square root of 9 will give you square root of 8 will give you what? I've already given you the answer. So that 9 coming outside, you need to multiply the fraction over there. That will give you, so the 3 denominator there will cancel the 9. And our result will be 6. 6 to 2. Now you can see we have the common roots, right? Now we can add their 4 equations. So this is the strategy. We write all the coefficients together in one common bracket. So we have here 6 plus 30 plus 6. All against what? 2. Now final answer. Our final answer will be, what will be the result in the bracket? 42. So 42, and that is our final answer. Are you okay? Okay. Let's look at the multiplication of 6. Let's look at these 2 examples. Let's look at these 2 examples. So for the first one, it is also expressed in the form of 2 binomials. So as it says, how we get it for the 2 binomials, do the same thing. Again, this time we have what expression of what the square root inside, right? So the first bracket is always multiplying the second bracket. So let's do that. So we take all the elements in the first bracket out. So we have root 3 taking out, multiplying the second bracket. 2 minus root 3. Then negative 1 taking out, multiplying the second bracket. 2 minus root 3. Then what do you do? Now expand the simple one. So we're going to expand. Okay. So root 3 times the first element in the bracket will be 2 root 3. Good. Whenever the same roots are multiplying, what do you do? What do you do? What are you going to get? The same root number. Good. So root 3 multiplying root 3 will give you what? Negative what? 3. And we have here negative 1 times. So that will give you. Then negative 1 times negative 3 give you root 3. Then let's simplify this. Let's do items. We have root 3 here, but this one does not contain any roots. So it's also been classified in one